Okay, so this is brief notes on rules for counting atoms. So first, there are three key things we have to do when we're counting atoms. You have to consider subscripts, coefficients, and parentheses. So for subscripts, and this is in your OneNote, subscripts refer only to the atoms they are following. So here we have H2S, so that 2 only applies to the H, not to the S. So there are 2 hydrogens and 1 sulfur. So here's where they look. So here we have NH3. So this would mean NH3 means there's 1 N, and then for the H's we have 3 H's. So there's 1 N and 3 H's. That's how many we have. Here we have MgCr2O7, which is magnesium dichromate. So for the magnesium, we have 1 magnesium. We have 2 chromiums. We have 7 oxygen. So that's how you use subscripts. Coefficients, these are just like in math classes, numbers in front. And so numbers in front, they apply to everything. So you're going to multiply by it. So in this example, there's a 2 H2S, that means 2 times 2 for the hydrogen, and 2 times 1 for the sulfur. So if there isn't a subscript, that means there's only 1 atom. So a couple of examples. So here we had our 4 NH3. So now there's 1 N and there's a 4 in front. So the 4 is going to multiply that. So that means we have 4 nitrogens. And then 4 times 3 is 12. So we have 12 hydrogens. Here for the magnesium, the 2 times 1 means we have 2 magnesiums. And then 2 times 2 for the chromiums means we have 4 chromiums. And then the 2 times 7 for the oxygen means 2 times 7 is 14. So we have 14 oxygens. So that's how you use coefficients. It applies to everything in the atom. Finally, we have parentheses. This is just like math class. So in math class, normally you have something outside the parentheses when you're multiplying it. In chemistry, we put the number outside the parentheses behind it, but you still multiply it. So here we have BaOH2. I just realized in my example on the next slide. So the 2 applies to the H, to the O and the H, but not to the Ba. So, for example, that's what I get. So 2 times 1, so that means we have Ba. There's 1 Ba, because there's no subscript on the Ba. That means we have 2 oxygen, and we have 2 hydrogen. Here a little more complicated. We have our NH4, it's ammonium phosphate. So 3 times 1 means we have 3 nitrogen. We have 3 nitrogen, and then 3 times 4 means we have 12 hydrogen. But then we have to keep counting because now we have the PO4, so that means we also have 1 P, and because of that subscript we have 4 O's. Okay, so that's how you use parentheses. So let's do a couple of these together. So now we have the subscript. We have the parentheses, and we have the coefficients. We're going to multiply everything. So this one, that's 3. So we have 3 BAs because there's 1 BA times 3. Now we're doing 3 times the O, but we also have that subscript in there. So we actually have 2 O's here. The subscript means we have 2 oxygens, and then we're having that 3 times. So 2 times 3 is 6. So we have 6 oxygen. We have 2 times that, so we have 2 hydrogen times 3 means we also have 6 hydrogen. See, this is the same. This 3 is basically the same as writing BaOH2 3 times. BaOH2, BaOH2. So that's why we have 3 BAs. And then there's 2 oxygen here, 2 oxygen here, 2 oxygen here, 2 oxygen here. That's where you get the 6. Same with the hydrogen, same with the hydrogen. So again, here, gave you a nice hard one, right? So we have our nitrogen, we have our hydrogen, our phosphorus, and our oxygen. So here, inside the parentheses, we have 3 times 1 times 5. So 3 times 1 is 3, times 5 is 15. So we have 15 nitrogens. And then 3 times 4 is 12, right? And then 12 times 5, 12 times 5 is 60. So we have 60 hydrogen. And we have 1 phosphorus. 5 times 1 is 5. And then 5 times 4 is 20. So there's a lot of stuff here. And then eventually we're going to start talking about chemical equations. So that's how you count atoms. We're eventually going to talk about chemical equations. Now we have stuff, talk about this. When you have an arrow, this is kind of our equal sign. So over here, we're going to count everything we have over here. So here we have Na. So we have 3 NAs right here, right? 3 NAs. And then we've got 3 times H. So there's 3 H's right here. We have 3 H's here, but then we also have 8 H's right here. So 8 plus 3 is 11. So we have 11 H's over here. And then we have 3 times the carbons. We have 3 carbons here, but then we also have 6 carbons here. So that's a total of 9 carbon over here. And then for the oxygen, 3 times 3 is 9. So we have 9 oxygen here, plus the 7 oxygen here. So 9 plus 7 is 16 oxygen. This is more advanced stuff that we'll do with balancing equations. The same thing over here. We have 3 sodiums. We've got 6 carbon right there, plus another 3 carbon right there for a total of 9 carbon. We have 5 hydrogen right here. We have 3 times 6, so there's 6 hydrogen here, 5 hydrogen here, 5 plus 6 is 11. And then we've got 7 oxygen here, 6 oxygens there, so there's 6 oxygen. We have 7 oxygen, and then we have 3 times 1 is 3. So that gives us, Mr. Stockdale can't count today, 16 oxygen. 3 plus 6 is 9, plus 7 is 16. So this is an example of a balanced chemical equation. That's what we're going to get to. But this is what you have to be able to do. You have to be able to count all these stuff up. Okay? All right.